In last lecture, we talked about the elimination process with certain values in terms of geometry, column picturization, row picturization, that how the vectors are graphically presented. All this linear algebra. Linear algebra comes from basically completion and balancing. Completion and balancing. It comes from the word, Arabic word algebra, and by alpharmy. So in the theme of vectorization and you can say matrix composition, completion and balancing. So in the row picturization, in the column picturization, our aim is to achieve the balancing in terms of completion. So here in last class we talked about the linear system. There are too many linear systems, and each linear system is a way to get the solution set. Okay. In my last class, I explained different versions of linear algebra, and I tried my best to explain the theme. In today's lecture, I would like to mention it that the basics of linear algebra come from the word algebra. This Arabic word algebra. The meaning of this is completion and balancing. Though we can say the concept of linear algebra is utilized in our life to complete it and to balance it. However, sometimes we are getting a unique solution. To complete our real life problem. Sometimes we are getting no solution. Or we want to keep our life in a parallel way. Okay? We want to run. And sometimes we want
many solutions.
Too many solutions are infinite number of solutions. Finite solutions. We talked about too much about the unique solution. Let me explain a little bit about the no solution, or you can say the infinite many solution. For example, we have a linear system. Another linear system. Graphical notion tell us very simple and very clear about it. X-axis and y-axis in two dimension. If we are considering the first one, this linear system, by assuming the value of x equal to 0, we will get, if x on x-axis, if we are considering it 0, the value of y will become what? 8. At this point. This is the y-axis. If we are assuming the value of x equal to 1, then what will be the value of x is 1, then what will be the value of y? 6. By connecting these 2 points together and by extending it both sides, we will get this line. For second system of linear equation, for 0, by assuming value of x equivalent to 0,
Y is equal to 4.
Y equal to 4. By considering x equivalent to 1, what should be the value of y?
2.
As 1 value is 2. By connecting these two points, by extending both sides, we will get this parallel system. So no interaction. If there is no interaction, no unique solution is possible. So technically, no meetup, no solution will possible. So we say no solution. For example, on a road, we want to have a safe travel or safe journey to avoid the accident in a self-driving car, in our own car. We want to avoid the collision. We want to avoid the crashes. So no solution is required in this case. Okay? Nothing is useless. Linear algebra is encompassing the varieties of life problem. Sometimes we need a no solution system. Okay? Or no solution means no interaction or no collision or such kind of system where we cannot crash the system. Is it okay?
Yes, sir.
Our aircraft or our aviation systems, in the if two aeroplanes are colliding, so if we are in a big trouble. Okay, so this is the usage of no solution. Similarly, if we are considering one another system, there are two linear equations, or you can say two linear systems. So with the help of graphical notion, we easily understand, interpret what is going on. So by assuming the value of this equation, value of x in this equation for 0, what will be the value of y?
8.
If x equal to 1, what should be the value of x?
6.
By connecting, so this is the line. Moreover, by bothering the second linear system, this one, for x equivalent to 0, what will be the value of
8.
For value of x1, what should be the value of y?
6.
So
On each other.
overlap on each other.
Solution.
Is it okay?
Yes, sir.
If we see, so this is, or you can say, infinite number of solutions. Many times in our real life problem, we need infinite number of solutions. For example, for getting a rain from the clouds with the artificial way, in order to burst the clouds, we need to determine infinite number of points where collision in the droplets can be happen, okay, for occurring of rain. There are many things. You can see in you people, okay, why everyone want to join the computing domain, to get admission in computing domain? Because now the trend in this world is about computing. You should try to understand it, but with the help of, without mathematics, this is just, okay, learning kind of only kind of clinical things, to point the keys. You will not utilize your sense, nothing will happen. You cannot do any wonders. So here is one example. For example, someone is robbing the bank. Some thief, some robber is robbing the bank and running away. Police want to capture him. So if the speed of this robbery person is slope is what? Rise over run. Okay, this is the theme. So there should be for getting point of intersection, for unique solution, for capturing it. Unique solution does not make any sense if you don't know how to use it. How, in what kind of application you can interpret it, okay? So this is the speed, okay? You need to keep the speed higher than this if you want to capture the robbery person within certain limit. You can reduce the speed 170 if you want to capture somewhere here, or if you want to capture somewhere, you can make a speed at 160, okay? But if you want to capture the robbery person, or you can say robber at the earliest moment, of course, you can maybe boost your speed, maybe 280 or somewhere here, point of intersection. It's possible. Are you getting the point?
Yes, sir.
However, what will happen if the speed of a robbery person, speed of a police car, so no chase nearby will possible. No interaction. No unique solution.
They can fight.
Huh?
They can fight.
Yeah, but I just saying computing model, computing model. Okay? You want to arrest him, you want to capture him, there is another thing. But however, they are colliding on a road, there are infinite number of solutions. They can be, okay, fired, or you can say, they, in the accident, they can be, and maybe policeman can be killed, or maybe the robbery person can be killed. Yes. Anything is possible. Maybe no one can be captured. But there are infinite number of solutions.
पुलिस की गाड़ी उसकी गाड़ी के ऊपर है.
Maybe okay, both the cars damaged. You can say, but you can say there are too many solutions. Okay.
Yes.
So overlapping is the thing. Infinite solution. So linear systems will provide you the unique solution, sometimes no solution, sometimes infinite number of solutions. Before this you are studying in your books that matrix is doing this, now today you can see it. Yes. Is it okay?
Yes,
sir. Thank you so much. Similarly, if you want to step advance, kind of machine learning, kind of deep learning, you can notice this kind of complicated equation. This is a Russian model where they want to predict the price of house. Okay, prediction. So house price, A is a, you can see intercept, like in equation of line, y equal mx plus b. B is what? From where we start our business. Yes. Pocket money. Here, concept of house, fulfill the basic criteria of house. One room at least, one bathroom, one kitchen, at least such kind of things. So you can say it is a house. Otherwise, only single room, or you can say a shop, you cannot say it's a house. Are you getting the point?
Yes.
If you want to determine the prices of house, you are observing in some area, you want to get a house on a rent, you need to observe one thing, this should be basic, fulfill the criteria, it is the benchmark standard. Or you can say it's the basic least level. Okay? So it's kind of, so another is the parameters, certain parameters. For example, it is how much from the school, how much from your university. This is what x1 is the distance, b is the distance related to the school. This is the first parameter. Second one, number of bedrooms. If you want to need a spacious house, so depend on number. So how many numbers? Okay, this is the parameter. Similarly, there are n number of. It should have some kind of fabulous designing, or fully furnished, or this kind of kitchens, or fully gold taps in the washrooms. So it's better part. Okay, come on. There are many designs. Okay, yes. But you should reach. Okay, listen. Next, of course, you want to observe 10 or 100 houses in some particular area for buying purpose, for renting purpose. So, its number, okay, I is representing, of course, Y is, sub I is predicting the prices of the house. But you can see, this is the same. Intercept level is same, that it should be a house, not a shop, not some kind of a garage. Are you getting my point?
Yes.
So rest are the features. Features are changing. So if the features are changing, of course, price of the house will be changed. Are you getting the situation?
Yes, sir.
And when you are eliminating these features with respect to some your requirement, of course, with the help of elimination process, you can do it. Okay, so you want to determine the inverse of this. This is the given matrix, kind of given matrix. You need to determine some kind of inverse of it. Okay, let me explain it. So there are many contemporary applications in machine learning, in deep learning, for determining the values depending upon the parameters of them. Are you getting the in previous example I explained there are certain values of a house, but depend upon the parameters. So similarly, you want to design some circuit, okay? Complication of circuit, for example, your supercomputer or your I-cores, I3, I5, I7, it depends upon the parameters. It depends upon the RAMs. It depends, okay, are you getting the price of the laptop will be increased?
Yes.
Everything, okay, not only price, efficiency, computing power, everything, okay?
Yes.
Child is, you can say in the first class, hardly know that how to write ABC or how to understand, pronounce it. But at the later, once the life is growing up person like you people, you are playing with the teacher. Okay, so sometimes, and for this purpose, once we are becoming clever, of course smart enough, we are eliminating the useless thing. We are elimination process. So for elimination process,
They are developing robotics.
yeah, this one is the some basic system. Identity. Nothing, there is nothing but in your mind. Okay, but in your mind. Here I is representing what? Identity matrix. If you are talking about the identity matrix, talking about any matrix of 3 by 3, because it depends upon the linear systems. Sometimes linear system can be of 100 equations, 100 rows, 100 columns, or maybe number of columns can be increased or decreased. Similarly, number of rows can be increased. But here we are talking about it with our system 3 by 3. Okay. So this A inverse A can be written like, if you studied about commutative associative property, you can say, is it okay?
Yes, sir.
And if I say here A inverse labeled with some matrix B, because we don't know A inverse. We know the A, but we don't know the A inverse. Because here identity matrix help us to determine it with the help of elimination process. So you have this matrix B, of course, unknown value. In case of 3 by 3 matrix, you can say we have first in sub values, first one represent what?
Rows.
First one represent
Rows.
rows, and in the second one represent columns. See, second one represent column. Technically, we need to determine this one. All these unknown values, A inverse. Why we need of this? I would. You people know about CT scan.
Yes.
In CT scan, sometimes a person is passed through
machine.
A CT scan machine for getting its scan, its body scan. Suppose the person images is storing on some CCD charge coupled device. Information is storing. Continuous information inside of a body is storing on a CCD charge coupled device in discretized form. Discretization. Okay. Technically, in our body, in everywhere, tons of information. But once we are capturing in on some media, it's captured in form of a discretization pattern. And suppose this one is a discretization pattern. And if we are considering the CT scan machine around the body is passing through, and of course gamma rays from various direction is passing through the body. If gamma rays is passing through from this side, here it is storing somewhere. If the bone, for example, there is some bones, gamma rays will be absorbed by the strength of the gamma rays will be absorbed by the bones, and limited amount of energy will be reached at the CCD charge coupling device, okay, or the storing media. Similarly, if there is some kind of a water inside of our body, of course, better energy than the bones will be reached to the storing media. If there is a air pocket inside of our body, of course, much better, you can say, our maximum energy will be reached to the storing media. Okay, this is information stored from the human body in form of matrix A. Because all these, this one is what, linear system, this one is a linear system, too many equations, number of equations will be stored in form of an array. And A is what? Matrix. With too many values. But once the storing process or the CT scan process is completed, human body is moved away from this machine, and clinical expert will observe the information of that human. From where? From this storing data. So from this storing data, what will it do? The computing, you people, will help him out to determine the image of a body with the help of, so this is the A, you will provide A inverse. Are you getting my point?
Yes.
So A inverse is basically not the complete information, not the continuous pattern, but discretized, limited information. Okay? From this limited information, clinical expert will observe. Sometimes we can say that machine is the positive, false negative. So this is not accurate result because limited information. Are you getting the point? So A inverse will help us to tell the pattern once there is no body. So here, this one, it is going layer by layer. First, we are considering here A, X, B. So here, what's the A? A is the original matrix. X is what? X is this one. B11, B21, B31, and B is what? Basically, B is 1 0 0 0 1 0 0 0 1, and this is the first column only. Okay, 1 0 0. So you are getting the first column values. How? Like this. Okay, from this equation, X A inverse B. But computing process, we need to determine, this is the step by step, okay? First value solution test, second, then last one. But we can do with the help of identity matrix. If we have some matrix 1 1 1 1 2 1 3 4 2 this is matrix A. From this matrix A, we want to determine A inverse. We can consider an identity matrix 1 0 0 0 1 0 0 0 1. With the help of elimination process, we can get rid of these values 0 0 0. Here we can make it 1 1. Are you getting my point?
Yes.
So for this purpose, I can say by making these values 0, what will we do? Okay, row. So we will subtract second row from the first one. What will happen here? 0 1 1. Is it okay?
Yes, sir.
So for third one, what we will do? R3 minus R1. Okay, here remember, if we will do R3 minus R1, this will become minus sign. So it's better we should consider the simplicity purpose. We should do R1 minus R3. R1 minus R3, this one is the minus sign here. It will subtract it from this positive value and we will get 1 here at the top.
तो ऊपर 0 हो जाएगा सर ऊपर में आ जाएगा फिर एक्सचेंज करनी पड़ेगी
Okay, let's see if here R 1 minus R3.
Sir, minus R3 plus R1 sir.
The same thing.
Sir, अगर R1 पहले लिखेंगे तो operations में 1.
No. We know for what we are doing. Okay, we are talking about the third row. Okay.
सर है उसमें माइनस आने थी
Yes, sir, minus R1.
So she said that we should write like this.
Yes.
R3 minus R1 सर
Minus R1.
Minus R3.
माइनस आ जाएगा तो क्या है
Is it fine, my daughter?
Yes.
Okay, so here 0, 0. So 3 here minus 2. So 1. Is it okay?
Yes.
Now that's okay. So same operation will be performed on the identity matrix. So 1 0 0 on second row. What we will do? Minus 1 1 0. For the third row, what we will do? Here minus 1 0 1. Is it clear? Any objection? Okay, proceed to the next step. Because now what we want to do, we want to get rid of these value equivalent to 0. So with the help of this last value, it is very easy to subtract, get first here this 3 becomes 0. Row 1 minus 3, third row subtracted, we will get 1 1 0. Here 0 0, so only this will be cancelled out, so 0. For the second row, R2 minus R3, we will get 0 1 0, so 0 0 1. Similarly, if we will apply the here, remember this point, okay? So we will multiply row third with minus 3 plus 3. Okay, minus 3 will be added up here. We will get minus 2 and this 3 will go here. So minus 2, 0, 3. Minus 2, 0, 3. Similarly, my children, if we will perform a row operation on the second one, okay, we just need to subtract row 2 minus, so minus plus. This minus minus 2, so minus 2, 1, minus 1, plus 1. Minus 2, 1, 1. So we can keep the last row as it is.
1 0 minus 1.
1, 0, minus 1. My children, now the next one, it's very simple. You can say R1 minus R minus R2. So, please, this is A inverse. A moment ago, I explained what, my children, you need A inverse. Okay?
Yes, sir.
In application, you need to determine the A inverse. For a purpose, you need an image. Is it really difficult? No, okay, it's not difficult. Let me give you one more example of it. Okay, see this matrix. This matrix, let me explain the process in very simple format. So, these are the column, okay, of this matrix. These are the rows of this matrix. Of course, you need to determine the solution set. And in solution, basically this is what? Linear systems.
Corresponding equation.
Systems. Linear system, corresponding equation. And of course, these are the values you want. You can, this is the kind of a linear combination, picturization form. I already explained to you people, 2 by 2 okay, matrix picturization form, column picture. So if we see this here, first, okay, for first plane, because it's a 3-dimensional, okay. Here, at of course this point, this is the point of intersection. In 2-dimensional, it was easy to portray on this whiteboard 2-dimensional space, but in 3-dimensional, I'm using this graphical. So solution set is this one. So here you are getting it in the middle somewhere. Of course, this is giving you the value of, if you have the 3 dimension here in this case, this is the first vector, this is the second vector, this is the third vector. You are taking what? You are getting the resultant vector or rectangular component. These are the components. This one is the resultant one. These are the components of this resultant one. And if we expand, or you can say if we extract the true information of this, this is going like here, this, and this is going like this, okay? So maybe somewhere I use the slide. No? Okay. So this one is the, basically the theme is this, it is reaching to this point, but your vectors are concatenating with one another and lead you to the final point.
Yes, yes.
Okay? These are basically components of the vector B, 3 vectors. So this math basically helps you out to determine the system. For example, if we say some example in front of you people, So it's kind of a magic trick. If you want to pick any number and delete that row and that column of number, you need to choose 3 numbers from it, anyone you can choose, and if you are summing up these 3 numbers, you will get an answer 11. That is the magic trick.
Yes.
Are you people familiar with it?
Yes.
How?
No, sir.
No, sir, we are not.
Okay, for example, choose any number. Yes. 5. Next. 5. One number. 5. Okay, this one row eliminate, this one column eliminate. Yes, next number. Yes.
3.
3.
7. 7 eliminated.
Okay. So, okay, one already eliminated, you don't pick it. 3. So
सर ऐसे करें एक ही रो रहेगी कॉलम में.
So you can add up, you can get 11. Do you know what I did? Basically, not magic. It's the mathematics. You can make any kind of matrix, not only the number 11, okay? Let me explain to you. For example, you are writing, in this case what I did, so here is there anything inside of it?
No.
Just like a patient body. Now there is no patient body. Information is in surrounding. Information is in surrounding. Let me fill it.
Yes.
Okay. First of all, 3, 1, 4, 4 and 2, 6, 6, 7, 7 and 4, 11. This is 11. Anything inside of this box? No. But we know matrix is telling you how to help out to predict the values, okay? Here's nothing. Inside from the storing media we get inverse of the matrix. How? 1 and 2, 3 add up. 1 and 1, 2. 1 and here, so 3 and 1 and 3, 4. 4 and 2, 6. 4 and 1, 5. 4 and 3, 7. 0 and 2, 2. 0 and 1, 1. 0 and 3, 3. My children, see. Now you can from this inside, no information outside. You can retrieve the data from there.
Yes.
Okay. This is very, very simple, okay, very, very simple stuff. But complicated problems, complicated systems can be observed with the help of linear algebra. This is not a magic. Basically, the people around the globe playing a tricks in front of the audience, they are using the linear algebra. They are mastering in that field. Is it okay?
Yes, sir.
Yeah. Okay, thank you. Any questions?
No, sir.
Yes, please. Oh, thank you.